Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. We discuss physical properties of oxalic acid, preparation of oxalic acid from molasses in this lecture number 22. Firstly, key concepts of this lecture. We discuss introduction of oxalic acid. Then we will discuss physical properties of oxalic acid. Physical properties include color, odor, melting point, boiling point, molecular formula, molecular weight, enthalpy, entropy, crystalline structure, heat of decomposition, heat of solution, heat of sublimation, and reducing agent. Then we discuss molecular formula of sucrose, including structural formula, applications of oxalic acid, types of process available for the synthesis of oxalic acid, reason for selection of this process, and then we discuss flow sheet information and what are molasses. The last one we will discuss properties of molasses. Now, what is oxalic acid? Oxalic acid is an organic compound and colorless crystalline substance with sharp and sour taste. Now, what is organic compound? Organic compound, any of a large class of chemical compounds in which one or more atoms of carbon are covalently linked to atoms of other elements, most commonly hydrogen, oxygen, or nitrogen. The few carbon containing compounds are not classified as organic, including carbides, carbonates, and cyanides. A crystal or crystalline solid is a solid material whose constituents such as atoms, molecules, or ions are arranged in a highly ordered microscopic structure forming a crystal lattice that extends in all directions. In other words, crystalline solids have a well-ordered shape with repeating units. Due to the symmetry of their solids, they have a sharp melting points. Crystals are composed of three-dimensional pattern, and these patterns consist of atoms or groups of atoms in ordered and symmetrical arrangements which are repeated at regular intervals, keeping the same orientation to one another. Now, what is lattice? A lattice is simply an arrangement. A lattice is an ordered array of points describing the arrangement of particles that form a crystal. The unit cell of a crystal is defined by the lattice points. Now, what is crystal lattice? The definition of crystal lattice is the arrangement of atoms, molecules, or ions of a crystal in the form of a space lattice. Oxalic acid is a part of carboxylic acid family. Any of a class of organic compounds in which a carbon atom is bonded to any oxygen atom by a double bond and a hydroxyl group by a single bond. A fourth bond links the carbon atom to a hydrogen atom or to some other univalent combining group. The carboxyl group COOH is so named because of the carbonyl group and hydroxyl group. At high concentration, it could prove to poisonous. IUPAC name of oxalic acid is ethane dioic acid. Common name is the oxalic acid. The molecular formula of oxalic acid is COOH bonded with another COOH. Molecular weight of oxalic acid is 126. The melting point of oxalic acid is 187 degrees Celsius. Now what is a melting point? The melting point or liquefaction point of substance is the temperature at which it changes state from solid to liquid. At the melting point, the solid and liquid exist in equilibrium. The compound exists in anhydrous form or as a dihydrate. The anhydrous acid is not found in nature and must be prepared from the dihydrate even when produced industrially. Anhydrous literally means no water. In chemistry, substances without water are labeled anhydrous. The term is most often applied to crystalline substances after the water of crystallization is removed. Anhydrous oxalic acid is slightly hygroscopic. It absorbs water from moist air, whether to form the dihydrate again. The hydration occurs very slowly because of surface caking. And what is hygroscopic? A substance tending to absorb moisture from the air. A hygroscopic substance is one that readily attracts water from its surrounding through either absorption or adsorption. Examples are honey, glycine, ethanol, methanol, concentrated sulfuric acid, and concentrated sodium hydroxide. Oxalic acid is widely distributed in the plants and animal kingdom, nearly always in the form of its salts, and has various industrial applications. The urine of humans and of most mammals also contains a small amount of calcium oxalate. In pathological cases, an increased calcium oxalate content in urine leads to the formation of kidney stones. Calcium and iron oxalates are also found as minerals. Calcium oxalate crystals are the most common cause of kidney stones. These are the hard clumps of minerals and other substances that form in the kidneys. These crystals are made from oxalate, a substance found in foods like green and leafy vegetables, combined with calcium. Oxalic acid is simplest of dicarboxylic acid. Oxalic acid is an organic compound with the formula of H2C2O4. The name of oxalic acid is derived from the Greek word oxys, meaning sharp. acidic suffering to the acidity common in the foliage of certain plants from which it was first isolated. Foliage is the representation of leaves, flowers, and branches which are used in the architectural ornamentation. It is a colorless crystalline solid that dissolved in water to give colorless solutions. In terms of acid strength, it is much stronger than acetic acid. Oxalic acid is a reducing agent and its conjugate base, known as oxalate, is a chelating agent for metal. Oxalic acid is commercially available as the dihydrate containing 28.5% water. It is a monoclinic prism, particle size varying from fine powder to coarse granules, which are also colorless. Now, what is reducing agent? A reducing agent is typically in one of its lower possible oxidation states and is known as the electron donor. A reducing agent is oxidized because it loses electron in the redox reaction. The reducing agents give away electrons. The metals of the S block in the periodic table are said to be good for reducing agents. The reducing agent, after losing electrons, gets oxidized and also causes the opposite reactant to get reduced by supplying electrons. All the good reducing agents have the atoms which have low electronegativities and a good ability of an atom or a molecule to attract the bonding electrons, and species having very small ionization energies. All the oxidation and reduction reactions involve the transfer of electrons. When some substance is oxidized, it is said to lose electron, and the substance which receives electrons is said to be reduced. If the substance has a strong tendency to lose electron, then it is said to be a strong reducing agent, as it will reduce the other substances by giving electrons. Now, what is conjugate bias? When an acid dissociates into its ions in water, it loses a hydrogen ion. The species that is formed is the conjugate base. In other words, a substance formed when an acid loses a hydrogen ion. In crystallography, the monoclinic crystal system is one of the 7 crystal systems. In the monoclinic system, the crystal is described by vectors of unequal length, as in the orthorhombic system. They form a rectangular prism with a parallelogram as its base. Now, the oxalic acid melting point is 187 degrees Celsius of anhydrous form and 101.5 degrees Celsius of dihydrate form. Oxalic acid is one of the most widespread organic acids in plants. Applications of oxalic acid. It is a cleaning agent. Oxalic acid is used in the dyeing process as a mordant. Now, what is mordant? Natural dyes will not adhere to natural fibers. without the use of a mordant or fixative. A mordant or dye fixative is the substance to bind dyes on fabrics by forming a coordination complex with the dye, which then attracts to the fabric. Mordant not only give the dye an affinity, but in many cases they produce different colors and improve the fastness of a dye. Modern dyes are acid dyes that have special sites other than acid salts and ion groups that can react with a metal salt mordant. In lanthanide chemistry, it is used as an important reagent. It is applied on marble sculpture to make it shine. It is used in the manufacturing of dye. Oxalic acid is used in bleaches. Bleach is the generic name for any chemical product which is used industrially and domestically to clean and to remove stains. Now continuing the applications of oxalic acid. Oxalic acid is used in removing food and ink stains. It is also used in developing photographic film. Oxalic acid is used in wastewater treatment to remove the calcium deposit. Oxalic acid is used in garments and textile industries for the removal of ink stains. Oxalic acid is also used in the gumming of silk. Degumming is the process of removing the sericin or silk gum from silk. Removing the gum improves the sheen color, hand and texture of the silk because gum can serve as a protective layer. Oxalic acid is used in printing on cotton. It is used in polishing. Appearance of oxalic acid is transparent, colorless, odorless crystals. Solubility of oxalic acid is 1 gram per 7 ml of water. Specific gravity of oxalic acid is 1.65. Boiling point of oxalic acid is within the range of 149 to 160 degree Celsius. Now what is boiling point? The temperature at which the pressure exerted by the sounding upon a liquid is equaled by the pressure exerted by the vapors of the liquid. Under this condition, addition of heat results in the transformation of the liquid into its vapor without raising the temperature. Melting point of oxalic acid is 101.5 degrees Celsius and the vapor density of the oxalic acid is 4.4. Vapor density is the density of a vapor in relation to that of hydrogen. It may be defined as mass of certain volume of the substance divided by mass of same volume of the hydrogen. Now the physical properties of oxalic acid is continuing. Vapor pressure of oxalic acid is less than 0.001 at 20 centigrade. Molecular weight of oxalic acid is 126. Chemical formula of oxalic acid is COOH bonded with another COOH with 2 water molecules. It is a dihydrate form. Heat of solution in water is minus 9.58 kilojoule per mole. Now the heat of sublimation of oxalic acid is 90.58 kilojoule per mole. Heat of decomposition of oxalic acid is 826.78 kilojoule per mole, whereas the entropy is of oxalic acid at 25 centigrade is 120.08 joule per mole per Kelvin. What is heat of solution or enthalpy of solution? Is the energy released or absorbed when the solute dissolved in the solvent. If heat is released when the solute dissolved, temperature of the solution increases, reaction is exothermic and delta H is negative. The molar heat of sublimation is the amount of energy that must be added to a mole of a solid at constant pressure to turn it directly into a gas without passing through the liquid phase. For example, dry ice, solid oxygen, etc. Heat of decomposition. The heat of reaction resulting from the decomposition of a compound into its elements or into other neutral compounds, especially the quantity involved in the decomposition of a mole. In other words, the change in enthalpy accompanying the decomposition of one mole of a compound into its elements at constant pressure. And what is entropy? Entropy is an extensive property of a thermodynamic system. Entropy is represented by the capital letter S, and it is a thermodynamic function that describes the randomness and disorder of molecules based on the number of different arrangements available to them in a given system of or reaction. Oxalic acid is purchased usually in the form of oxalic acid dihydrate, which is a crystalline form with two water molecules attached to each molecule of oxalic acid. The compound forms colorless and odorless prisms or granules that contain 71.42 weight% of oxalic acid and 28.58 weight% of water. It is a monoclinic prism with particle size varying from fine powder to coarse granules, which are also colorless. Melting point is 187 degrees Celsius of anhydrous form. Oxalic acid is a normal metabolite of carbohydrates in normal quantities, for example fructose, glycine and vitamin C. Oxalic acid is readily soluble in porous solvents such as alcohol. Although partial esterification occurs, acetone, dioxane, tetrahydrofuran and furfural. Oxalic acid is sparingly soluble in diethyl ether. 1.5 gram oxalic acid dihydrate in 100 gram of ether at 25 centigrade, and insoluble in benzene, chloroform and petroleum ether. The ionization constant showed that oxalic acid is a strong acid. What are porous solvents? Polar solvents have large dipole moments, partial charges. They contain bonds between atoms with very different electronegativities, such as oxygen and hydrogen. Similarly, non-polar solvents contain bonds between atoms with similar electronegativities, such as carbon and hydrogen. What is ionization constant? An acid ionization constant is the equilibrium constant for the ionization of an acid. The acid ionization represents the fraction of the original acid that has been ionized in solution. Therefore, the numerical value of Ka is a reflection of the strength of the acid. Now, types of process available for the production of oxalic acid. There are many industrial processes for the production of oxalic acid which have been carried out. In other words, the literature survey brings forth a number of processes differing basically on the type of raw materials. The processes available are alkali or fusion of cellulose, synthesis from sodium formate, oxidation of ethylene glycol, oxidation of propylene, electrolytic process, fermentation process, and last one is the molasses of nitric acid. The reason for selection of any process depend on low cost, simplest operation, trouble-free, and availability of raw products in abundance. Flow sheet information for the production of oxalic acid. Name of flow sheet is the oxidation of molasses by nitric acid. Raw material which are used for the production of oxalic acid are nitric acid, sulfuric acid, water, and most important is the molasses. The crystals used are vanadium pentoxide, which are also used as act as a catalyst. Molasses. Molasses is the dark, sweet, syrupy, concentrated juice byproduct made during the extraction of sugar from sugarcane and sugar beets. In other words, molasses is a viscous byproduct of the refining of sugarcane, grapes, or sugar beets into sugar. The word comes from the Portuguese milaku, ultimately derived from mel, the Latin word for honey. A sugar beet is a plant whose root containing a high concentration of sucrose and which is grown commercially for sugar production. The quality of molasses depend on the maturity of the source plant, the amount of sugar extracted, and the method employed. Molecular formula of sucrose. Sucrose is a common sugar. It is a disaccharide, a molecule composed of two monosaccharides that are glucose and fructose. Sucrose is produced naturally in plants from which table sugar is refined. It has the molecular formula is C12H22O11. As you can see in the structure of sucrose, so sucrose is a molecule composed of two monosaccharides, namely glucose and fructose. This non-reducing disaccharide has a chemical formula is C12H22O11. This type of linking of two monosaccharides called the glycosidic linkage. Sucrose has a monoclinic crystal structure and is quite soluble in water. The molecular weight of sucrose is 342 gram per mole. Oxidation of propylene, electrolytic process, fermentation process, and last one is the molasses of nitric acid. Thank you very much.